Mr. Harridan here. Today we are going to go over the Schrodinger model of the atom here. It's very spooky stuff. That's what we're going to do today is some Schrodinger model stuff here. So there are four quantum numbers, okay? Now they gave these quantum numbers letters. They call them N, L, M, and S, okay? This is like your seat at a football game. You get to figure out your seat level here, your section number, the row, and your seat number. Kind of like for electrons, you got to figure out where the electrons are located here. This is all about figuring out where each electron is located. So Schrodinger agreed with Bohr about these quantized levels. However, Schrodinger differed in the fact that it does not find an exact path. Electrons do not travel in orbits. Okay? That's where they disagreed here. There is a high probability of finding the electron. This is called an orbital. That is where you find the electron 90% of the time. The electron is in the orbital. The other 10% of the time, the electron is not in the orbital. Hey, you know I found these sunglasses in my room. Somebody left them in my room. Yeah, if you left your sunglasses in my room, you have them. Anyways, so we're going to go over electron locations here, okay? Just like your seat at a stadium here, you got to figure out your electron locations. Okay, and we're going to start off with the first quantum number, which is called the N, the energy level. It is a number from 1 to 7. Okay? It indicates how far you are from the nucleus. So the further the nucleus, or the electron is away from the nucleus, the higher the energy of that electron. You can figure out the number of electrons for any energy level. There's an equation called 2n squared. Okay? So, the first energy level, which will be just that right there, first energy level, if I move my paper up so you can see what I'm trying to do. That would be nice, Mr. Harridan. Okay? This is the first energy level here. You do 2n squared for this. So 2 times 1 squared is 2. The second energy level, distance from the nucleus here, that's what the energy levels tell us. 2n squared, we're going to get 8 electrons for the second energy level. For the third energy level, distance 3 away from the nucleus here, that would be 18 electrons, because 3 times 3 is 9, times 2 is 18. And the fourth energy level is 32 electrons, which is the fourth energy level, right? Okay. So when you see me drawing these here, I'm referring to the n. So this is n equals 1. This is n equals 2. N equals 3. And n equals 4. When I do my energy levels like that. Moving on to the next page. Page 6. Talk about the second quantum number, okay, which is L. I got so much stuff in my way, Mr. Harridan. Come on, Mr. Harridan. You got this, Mr. Harridan. You're a champion. Oh, you need to get the notes on the screen, Mr. Harridan. Yeah. Get the notes on the screen. There you go. So we're going to talk about L, the sublevel. The second quantum number. This is the shape of the orbital. There are 4 shapes. S, P, D, F. Okay? Each energy level is divided into a sublevel, which is the second quantum number L, which is use a letter. This is the shape of the region. There are 4 of them: S, P, D, and F. The first energy level has an S. Okay. The second energy level has an S and a P. Okay. The third energy level has an S, P, D, and a D. And the fourth energy level has an S, P, D, and F. Okay. So, the S sublevel is a sphere shape. Okay. The P sublevels are called dumbbells or hourglasses. Sometimes they call them dumbbells. Like the weights, they call those dumbbells that you do weights, like when you're lifting weights. I don't lift weights, you know. I know, that's pretty sad that I don't lift weights, but you know how it is. Okay? And the D and F have weird shapes here. Okay? So this is the S orbital. Okay? There is one type of S orbital. P orbitals. There are 3 different types because they are on 3 different axes. There's one on the X because it looks like this. There's one on the Y and there's one on the Z. Okay. These are the D orbitals. There are 5 of those. And then finally, these are the F orbitals. Okay. There are 7 of those. Okay. Okay, the third magnetic number here. Magnetic quantum number, Mr. Harrido. Get your terminology right here. These are the orbitals. Each sublevel contains an orbital, which there is a high probability for finding electrons, which is the orientation of those orbitals. Number of orbitals is related to L. Each orbital, oh, this is very important, Mr. Harrido. My face is probably covering all the notes. Muy importante. Muy importante. Each orbital can hold 2 electrons. Okay? Surface of the orbital shows that the electron can be found there how many percent of the time? 90% of the time. Okay? Each sublevel has a number of orbitals. Okay? The S has 1 orbital, which looks like a sphere. The P has 3 orbitals. They look like dumbbells, and they're in different points. The D has 5. And I call these the butterflies or the clovers. 5 clovers. Okay? And the F has 7, which I have a hard time drawing, but these are like starbursts. They look like that. 3, 4, 5, 6, and 7. Now, here's what they do with these orbitals. These orbitals are on top of each other. So, you have the 1s orbital here. Okay? You put 2 electrons in that. Then there are 3 p orbitals here. Well, we gotta do the 2s first, Mr. Harrido. Gotta do the 2s next. After the 1s, you do the 2s. Notice that the 2s is bigger than the 1s because it's a bigger energy level. Put 2 electrons in there. Then you do the 2 p's, and then you put 2 electrons in the px, the py, and the pz. And then you go on to 3, and so on, and so on, and so on. Okay. So, we're going to complete this table here. Table is muy importante here. Okay? So, the first energy level, it only has an S. Okay? We are going to use a box to show the orbital. Okay? there are going to be electrons. I use arrows, those are half arrows, I'll explain that later, to represent the electrons. So there are 2 arrows, 2 electrons. So S's can only hold 2 electrons. And that pen does not look that good on me, so I'm going to try this one. Now we're going to do the second energy level. The second energy level only has S and P. S's there are 1 sphere. P's there are 3 dumbbells. And if each one of them has an electron, 6 total electrons there. 2 electrons for my S, 6 electrons for my P. 2 plus 6 is 8 electrons. Okay, moving on. Third energy level has S, P, and D. 1 orbital for the S, 3 orbitals for the P, 5 orbitals for the D. Bing bang. Put electrons in all of these. Should do it like this. Okay, so there's 2 electrons in my S, 6 electrons in my P, and 10 electrons in my D. That is 18 electrons. SPD. There you go. Then the fourth one has 4 energy levels, S, P, D, and F. S's have 1 orbital. P's have 3 orbitals. The boxes I am drawing represents the orbitals. The D's have 5 orbitals. And the F's have 7. Okay. That's 6 boxes, Mr. Harrod. I'm meaning a 7th box somewhere. There you go. You put electrons in each one. There's electrons in each one. Each arrow represents electrons. So there's 2 electrons here, 6 electrons here, 10 electrons there, and 14 electrons there. That adds up to 32 electrons. Okay? You can also get this number through 2n squared. If you do 4 squared, 16 times 2, it's 32. 2 ways to get the same number. Okay, now, gotta talk about the spin next. Everybody loves to spin. Yeah. Spin, spin. Fun for everyone. That's the 4 quantum number. Electrons must have opposite spins. See, here's the problem. Electrons are negative, and when you put negative things together, they like to repel. So, to prevent them from repelling here, one electron has to spin clockwise, and the other electron has to spin counterclockwise. Okay? So they use the spin number as a positive 1/2, that is an arrow up, or they can use the negative 1/2, that is an arrow down. Okay? Those represent spins of electrons. Okay, on to the 8th page here, Mr. Aaron. Come on, let's get to the 8th page here. That's what you want to try to get to. Alright, good. I was trying to get to that page, but I guess I'm not. Okay. Well, you guys are champions. The legend is out.